Hello! Today we are going to be taking notes on comparing and graphing ratios. This is going in your interactive notebook. Depending on your class, it's going to be somewhere in the 50s range. If you have questions about this after we're done with the notes, you can go back, you can pause, take the time that you need. You can also email me or visit me in class for some help. This is an extension of what we did on Tuesday, where we used the recipes, and we had two different recipes, and we wanted to see which recipe was more purple. Today we're going to talk about salsa, and looking at adding hot sauce to salsa, which batch of salsa is going to be hotter. This is from Big Ideas Math, pages 212 to 213. And one way for us to compare ratios is by using ratio tables. And I'm going to circle that because that's an important key idea, ratio tables. When I read a story problem, I like to mark the text. My mark the text process for a story problem is I circle the numbers first. Then I underline the words that come with the circles that explain what the numbers mean. And I box the question, and then if there's any other pertinent or important information, I'll go back and box that as well or circle it. So let's go through this together. You mix 8 tablespoons of hot sauce and 3 cups of salsa in a green bowl. You mix 12 tablespoons of hot sauce and 4 cups of salsa in an orange bowl. Which mixture is hotter? So my question is, which mixture is hotter? My numbers are 8, 3, 12, and 4. And I have 8 tablespoons of hot sauce, 3 cups of salsa, 12 tablespoons of hot sauce, and 4 cups salsa. I also know that this is going to be in a green bowl, this is going to be an orange bowl. So I've got a green bowl, I've got an orange bowl, I've got hot sauce to salsa in both. So the first thing that we're going to do when we look at these two different ratios is I want us to start off by making ratio tables. So our first step is make ratio tables and plug in, that's an and sign, plug in given ratios. So it gives us a green bowl has an 8-to-3 ratio, because you'll notice it's 8 tablespoons to 3 cups. The orange bowl has a 12-to-4 ratio, 12 tablespoons to 4 cups. So we're going to use those. And to create my ratio tables, I'm going to create a big rectangle. And this is going to be my green one, my green table. And then I'm going to create another one. What do you think it's going to be? Class? Orange. Right. I'm going to label it. So this is my hot sauce, which is in tablespoons. And this is going to be my salsa, which is in what? Class? Cups. Thank you. That's the measurement that we're looking for. Cups. I have to change pens because my pen is dying. Okay, we're going to do the same thing for this one. Hot sauce, which is in TBSP, which is the abbreviation for tablespoons, and salsa, which is in cups. Okay, now we got to put in those given ratios. So looking up at our equation, or our problem, we've got 8 tablespoons of hot sauce to 3 cups of salsa. So I'm going to say 8 tablespoons to 3 cups. Raise your hand if you can tell me what the ratio we're going to plug in for orange would be, looking at the information in our problem. Maddie?
4 cups, 12 tablespoons.
Good. All right, so that is step 1. You guys get it? You made your table, you plugged in your original ratio, we got it from our problem. Awesome. All our next step that we're going to do is we are going to make equivalent ratios for each table. So make equivalent ratios, which is the ratios that have the same value. And to do that, you want to make sure that it has the same, for each table, with the same value for one or the other units. So for either salsa or hot sauce. So what that means is you want, making another ratio over here, you want either this number to be the same or this number to be the same. And you do that by finding the least common multiple. Hey Dominic, you had your hand up for the last one. Can I have you help me with this part?
Sure.
Okay, awesome. Let me write this down and I'm going to have you help me. Alright, so Dominic, what I want you to do is, least common multiple is when you multiply a number out. So if you did like 3, 6, 9, 12, 15, that's multiplying it out, right? So we want to find a number that I can multiply 3 and get, and I can multiply 4 and get the same number. So can you think of a number that both 3 and 4 will go into?
They could both go into 12.
Right, because you multiplied 3 times 4 and you got 12. That is a perfect least common multiple. Do you guys agree with him?
Yeah.
Awesome. So we're going to put 12 over here. Because 3 times 4 is 12. That becomes our least common multiple. So now what we have to do is we have to find the missing terms. Alright, in order to find the missing terms, you're going to look at the relationship between this ratio and this ratio. Kind of like making an equivalent fraction. So you're going to look and see, well, what do I do to 4 to get to 12? Xander.
Multiply by 3.
You multiply 4 times 3 to get to 12?
Yeah.
So when we had equivalent fractions, didn't whatever we do to the bottom, we had to do to the top?
Yeah.
So can you help me, what is 3 times 12?
36.
Good. Now, Maddie, do you want to help me with the top one?
Yeah.
What do I do to 3 to get to 12?
You multiply it by 4.
I multiply by 4. Awesome. Got to do the same to the top, so what is our missing term then?
32.
32, because we multiply the bottom times 4, we multiply the top times 4. 4 times 8 is 32. We could keep going and we can make more equivalent ratios by just keep expanding out. But because we're just looking at comparing these two ratios to see which one is hotter, we can stop here because we have this common multiple. What this means to us, guys, is that for every 12 cups of salsa, in the orange bowl, you're going to have 36 tablespoons of hot sauce. In the green bowl, for every 12 cups of salsa, you're going to have 32 tablespoons of hot sauce. Can I ask you then, looking at that, which one do you think now is the hotter?
Orange.
Orange. Olivia, can you tell me why?
The orange is hotter because 36 is more than 32 and in the beginning the 12 is a lot more than 32.
Well, I'm going to stop you right there. You were absolutely right when you said that 36 is bigger than 32. That means that there's more tablespoons of hot sauce when you have the same amount of salsa. Maddie, do you want to add to that?
Well, actually, I have a question. Couldn't you do the same if you did?
Absolutely. So we decided to expand this out to find a common multiple that was bigger. You could also divide it back to get a common multiple of 1, and then you have a unit rate. For every 1 cup of salsa, how many tablespoons of hot sauce? You can go either way. That's a very good point. So the next thing we're going to do is we're going to figure out how much hotter it is by subtracting to find the difference in hot sauce. So what that means is we're going to look at how much hot sauce do we have in the orange?
36.
36, thanks guys. And how much hot sauce do we have, guys, in the green?
32.
So we subtract 36 tablespoons minus 32 tablespoons. You get what, guys?
4.
4 tablespoons more, which means the orange bowl is hotter because it has 4 more tablespoons of hot sauce for 12 cups of salsa. Are you following me on this, guys?
Yeah.
Does that seem reasonable?
Yeah.
Okay.
Oh, yeah.
I'm going to give you a second to write that down, and then what we're going to do is I'm going to go over to page 55, and we're now going to graph it. Because I want to show you how you can take the same data and we can put it on a data graph. So you can take a ratio table and you can make a graph out of it. One thing we're going to do before we turn the page, though, is I want you to look at our tables up here. When we use a coordinate grid, we have to have an x value and a y value. That's called a coordinate or a ordered pair. So we're going to say that our hot sauce is our x value and our salsa is our y value. And I'm going to put that as both of these tables. So our salsa is our y, our hot sauce is our x. Now when I go over to the page 55, when I create this this graph that we're going to do, I need to make sure that I label my x-axis as hot sauce and my y-axis as salsa. So now I'm going to flip the page. I'm going to, remember, you can go back to the notes if you need to. I'm going to create my y, which is my vertical, and my horizontal, which is my x. Remember, we said that hot sauce is our x. And it is in tablespoons. And our y is salsa, and it is in cups. Now, when we look at our two numbers for the green bowl and the orange bowl, I need to create ordered pairs. Remember, my ordered pairs are my x, y value. So if you look at your table, you're going to see we have an x for the first ratio and we have a y for the first ratio. That becomes your ordered pairs. So I'm going to flip this back over. Looking at my table here, guys, here's my first ratio for green. I have, what is my x value here? 8, right? Because the 8 is my first x. If 8 is the x value, what is my y value? 3. Julia, can you give me the next one for green? If it's 8, 3 for my first ratio, what is the second ratio that we found? 32 and 12. Very good. Can somebody give me my first orange? Xander.
The first orange was 12, 4.
12 and 4. Very good. What is my second orange? Dominic.
36, 12.
36, 12. Very good. All right, so now looking at those numbers that I have, on my hot sauce, which is my x, I have an 8, a 32, a 12, and a 36. Those are big numbers, right? I don't want to count by 1, because if I count by 1, I'm going to have a giant x. It's going to go really far, and or I'm going to squish it in so much that I'm not going to be able to read it. So what I'm going to do instead is I'm going to count by 4s, because I know that all of those numbers are divisible by 4. We're looking at just the x value. So just that first number, 8, 32, 12, and 36. Those are all divided by 4, right? So I'm going to go 4, 8. I should have given myself more room for this. 12. How about I'm going to do, because this is going to be really hard for you guys to see in the notes. It's okay if you didn't do it, but I'm going to fix myself because I made myself, I should have written this down here so I had more room. That probably makes it easier for you to read. And then I can do 4, 8, 12. Help me out. What's next?
16.
Good. 16. What's next?
20.
20. Next? 4.
28.
What's next?
32.
32. What's next?
36.
Last, let's do one more. 40. Okay? Alright, now let's look at the y values. We have a 3, a 12, a 4, and a 12. Writing between up to 12 is more reasonable. I'm just going to count those by ones. Okay, so going this way, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, look at that pretty little graph. Alright, so now we're going to do our green bowl. On the green bowl, our first value is 8, 3. That's our first ordered pair, right, guys?
Yes.
Remember with coordinate grids, what do we do first, the x or the y? X, right? You go over to x, and then you go up or down to y, right? So we're going to go over to 8, up to 3, which is going to be right here, and we're going to create a dot. I'm using green because it's the green bowl. You don't have to use green. I have the marker, so why not? Alright, let's go over to the next one. The over to 32, up to what? 12. So over to 32, up to 12, which is right here. I'm going to create my line. And this is the green bowl. Alright. Sorry, it's kind of hard to see in the screen. I can do, I don't know if you can see it in the notes, if it's showing up or not. Me trying to be creative and use green might have backfired. Oh, that's okay. Alright, so now let's do the orange, okay? What is on my first ordered pair of the orange? Where do I have to go first? Raise your hand and tell me. Julia? 12. Over to 12? And then where do I go up to, guys? 4. Over to, so over to 12, up to 4, which is right here. Okay? Then, I can do it in orange. Then where am I going to go, Maddie?
We're going to go 36 across.
So over to 36, up to 12. So all the way up here. Okay? And then I'm going to draw my line. I'm trying to make straight, but it's not great. And this is my orange. But I can notice when I see this data, at some point if it crosses, and I'm seeing a different rise, I see that they're starting to spread, and this one is getting to have, the orange is having more hot sauce. It's going further on that line. I do notice that here they have the same value, so that is where they equal out. So this gives me some data that I can use. So these are interesting and useful ways for you to record ratios and to compare ratios using a data table or a ratio table, and also using a coordinate grid. Understand with that coordinate grid, you always want to go to the X first and then the Y. That's a big key point. If you have questions or if you missed any of the notes, please go back and get them. Thank you very much and have a great day.